In this video, I will explain operation of monostable multivibrator using IC 555 operation. Here, block diagram of IC 555 timer. Here we use two comparators, comparator 1 and comparator 2. Comparator 1 is called as non-inverting comparator, or threshold comparator, Comparator 2 is called as inverting comparator, or trigger comparator. Comparator 1 is called as threshold comparator because the threshold voltage is applied to non-inverting terminal of the comparator 1. Comparator 2 is called as trigger comparator because trigger signal is applied to inverting terminal, that is minus of the comparator 2. SR flip-flop, set and this is the set and reset the flip-flop, and discharge transistor. Here 7th pin and the 6th pin are shorted. The capacitor is connected in between 6th pin and the ground. The resistor is connected in between VCC and 7th pin or 6th pin. Both are shorted, 7th and 6th is shorted. Here this line is indicates charging of the capacitor. This line indicates discharging of the capacitor. Solid line indicates charging of the capacitor. A dashed line indicates discharging of the capacitor. Now operation. Initially, the output is low. That means Q is equal to 0. So Q dash is equal to 0. Q is equal to 1. This is the output is taken at the pin number 3. Q is equal, output Q dash is 0. That is 0 here. Q dash is 0. Q is equal to 1. This one is NPN transistor. This high value is applied to this NPN transistor. The transistor is in saturation mode, driven into saturation mode. That means the voltage at 7th pin is 0.4 volts. In saturation mode, the transistor acts as a short circuit here. Short circuit and connected to ground. The voltage at this 7th point is 0.4. 6th pin is also 0.4 volts. The capacitor C is connected between 6th and ground. Therefore, the voltage at 6th pin is 0.4. That means nearly 0 volts. Therefore, the capacitor is connected between two grounds. The capacitor is discharges. That value is 0. Next, a trigger signal is applied to inverting terminal of the comparator 2. It is a negative going signal, pulse signal. Whenever that trigger signal, here the value at 5, the value is 2/3 VCC. Here the value is 1/3 VCC. This one. When the trigger goes below 1/3 VCC, the trigger signal value is less than 1/3 VCC. Here the value is 1/3 VCC is at a positive point here. Therefore, output of that comparator 2 is high because the trigger signal is less than 1/3 VCC. So 1/3 VCC is connected to non-inverting terminal of the comparator 2. Therefore, is at higher level. Therefore, comparator output is high. R is equal to 1. Q dash is 1. Q is 0. Whenever Q is 0, that low signal is applied to this discharge comparator, discharge transistor, not comparator, discharge transistor. The transistor acts as a closed switch, open switch. The transistor acts as open switch. Open switch means this point is disconnected. This point is disconnected from the 7th pin. Therefore, the capacitor is charged through VCC and resistance R. The capacitor is charged to towards 2/3 VCC, towards 2/3 VCC. Whenever the capacitor voltage crosses 2/3 VCC, the capacitor threshold, the capacitor voltage is connected to threshold terminal of the comparator 1. That means non-inverting terminal of the comparator 1 crosses the 2/3 VCC. Therefore, output of the comparator is high. Output of the comparator is high, and Q is also high. Q is high. Q is, whenever the Q is high, the transistor is in off condition, on condition. Again, the capacitor is discharged to 0. Here, initially, the output is taken at the pin 3. Initially, the output is low. The capacitor discharges. Trigger signal is applied. Trigger signal is applied. R is equal to, whenever the trigger signal is below that VCC, trigger signal is below that VCC, that is 1/3. Compare this trigger signal with 1/3 VCC. Below that 1/3 VCC, the output of the comparator 2 is 1. That is R is equal to 1. Q dash is equal to 1. Q dash is equal to which? 1 means maintains some high value. Maintains high value. The capacitor voltage is reached to 2/3 VCC because negative of the comparator 1 is connected to 2/3 VCC. The capacitor voltage is reached to 2/3 VCC. Compare these two. Therefore, the capacitor voltage is greater than 2/3 VCC. The output of the comparator is 1. Again, Q is equal to 1, and the transistor, discharge transistor is on. Low value here 0.4 volts at 7th pin and 6th pin, 0.4 volts. The capacitor is lying between 0.4 and 0. Therefore, capacitor is again discharges. Capacitor is discharges. And this voltage is also low value. Output at pin 3 is low value. Whenever the capacitor is discharges, the output at the pin 3 is low value. Here indicated, initially output low, Q is high, Q dash is low, Q is high, Q dash is low, QD is on, C is discharged. Trigger applied with trigger voltage is less than 1/3 VCC makes comparator output is high. That means R is equal to 1, Q is equal to low, Q dash is high, QD is off. QD is off means capacitor starts charging to VCC. The capacitor starts charging to VCC. VC becomes 2/3 VCC. VC becomes 2/3 VCC. Again, S is equal to 1 and R is equal to 0. Therefore, output R is equal to 0. Q is high. Q is high and Q dash is equal to low. Output is low. Therefore, QD on, capacitor discharged to 0 through Q. This is the action summary of monostable multivibrator. We know that VC is equal to, the voltage across the capacitor VC is equal to V final plus V initial minus V final into e power minus t by RC. VC is equal to 2/3 VCC. V final is VCC. In V initial means initial voltage across the capacitor is 0. V final is VCC into e power minus TC by RC. TC by RC. Therefore, 2 by 3 VCC is equal to VCC into here VCC plus VCC minus VCC into e power minus TC by RC. 2/3 VCC is equal to VCC into 1 minus e power minus TC by RC. VCC is cancelled. Therefore, e power minus TC by RC is equal to 1 minus 2 by 3. 1 by 3 e power minus T by RC. 1 by e power TC by RC is equal to 1 by 3. Cross multiplication. 3 is equal to e power TC by RC. Calculate TC from this expression. TC apply logarithm ln 3 is equal to ln 3 is equal to ln e power TC by RC. That is e power ln e power TC by RC. Therefore, TC is equal to RC into natural logarithm of 3. That value is 1.0986. RC is nearly equal to 1.1 RC. TC, the charging time required to capacitor is required to charge 2 by 3 VCC, that is TC is equal to 1.1 RC. This TC is also called as width of the pulse. That value is 1.1 RC. 1.1 RC.